I'm going to be talking about our security blueprint. That is basically a design guideline that we built to deploy the Checkpoint CloudGuard solutions. But the nice thing about the blueprint is that it's not specific to Checkpoint. You could use the design blueprint with almost any solution out there. We believe, of course, that our systems would perform best in many, many ways. But the main architectural design points that I'm going to be talking about can be reproduced with almost pretty much any vendor out there. I'm going to go and gloss over concepts and principles. I'm going to move a little fast because we had the mishap and we lost a little bit of time. And then I'm going to go a little bit deeper into architecture and solutions. I'm going to be answering some of the questions that were posted, and definitely if something does not get answered, it will be answered at the end during the Q&A. I'm going to fly through this. Obviously, the number of attacks on networks is not getting any smaller. This is, and information is beautiful, a graph of attacks and breaches between 2009 and 2011 compared with the last 2 years. So obviously, they are getting more frequent. They're getting bigger. They're not going away. They're just basically increasing over and over. We heard Binal saying that Azure has a lot of built-in security, and they do. Microsoft has an amazing set of tool sets to provide security into the network. So the usual question that we get is, exactly why do we need the partner solutions? What is it that they forgot? Or what is it that they're not covering? And I'm going to start by going through that. We, of course, have the identity management. Again, these are all the systems and solutions that Azure provides. And I'm going to go ahead and list them all. In addition to encryption, in addition to access control via security groups, in addition to deep inspection via web application firewalls or the Azure firewall, we have log analytics, we have configuration and management control via Azure policies. So indeed, there is a very complete portfolio of security to start. And if you look at the design that I have on the lower right-hand side, I have what is mainly an internal network. We have a headquarters that is connected to a couple of VNets in Azure. None of those VNets have a direct internet connection. Everything comes through the main system. So if we deploy all the native security tools in a cloud that is mostly private, most people feel pretty safe. So let's take a look at how safe that really is. I created a real quick Venn diagram. It's not going to be very, very nice, but I think it'll put the idea across of the overlaps that there are between the functionality that network security groups gives you, which is network trafficking, network traffic filtering rules. We're going to be adding the WAF to that, the app gateway that has web application firewall capabilities. It works as an ingress controller for AKAs and Kubernetes, but also performs a deep inspection of inbound web protocols. So that's pretty good. We know that Azure offers the Azure Firewall, which adds a big stack of add-on functions to the network security groups. It still does network traffic filtering, but it adds a lot of extra functions that were not there before. So to quickly illustrate, what would the third party add? This is what something like CloudGuard Gateway sort of adds capability-wise above and beyond what the native solutions Azure gives you today are. And none of these things would be important if they did not address attack vectors. So my next slide is going to talk about that. What attack vectors are really exposed by using only native tools? And I started thinking, I started jotting things down, and I came first with these 5, then with these other 5, then with these other 5, then with these others, and then with these others. So there is a need. There's a number of attack vectors that are left exposed, even when the clouds are purely internal and connected to the on-prem system. And most people say like, hey, but if my on-prem is protected, why do I need extra visibility and extra protection in the cloud itself, which is connected fully internally to me? And usually the example that I give is the inside or underneath a refrigerator. You know, your house is clean, you clean regularly, but one of these days you move the refrigerator and there's a lot of stuff in there that you have no idea how it got there. But if you don't clean and look in there every now and then, all sorts of things can proliferate, right? So definitely, as Binal mentioned, we are an NVA. We're a network virtual appliance, or at least the first half of our solution is. Our checkpoint gateways on the cloud are called CloudGuard gateways. It is the exact same software, the exact same Gaia OS that runs on physical appliances. They just happen to be running on VMs in Azure. If we just pop them in on the reference architecture that Microsoft presented, we get a pretty good idea of how we're mostly deployed, but that is perhaps not the best way to deploy them. And that is what I'm going to be talking about in the next few minutes. Just popping a couple of checkpoint gateways as an availability set, either as a cluster or either as a scale set, under simplified reference is perfectly fine if you have just one or maybe two VNets. But as Microsoft pretty much states, if you do a simplified deployment, you're going to end up with a lot of duplication of services. We have here basically in production, we deploy a pair, maybe in development, VNet, we deploy a pair. But what if instead of 2 VNets, we have 200 VNets or 400 VNets? We really don't want to have 400 or 800 checkpoint firewalls, right? So there are challenges to scaling this. There are licensing cost implications of putting a pair of systems on every single VNet. So we look again at the design, and the next recommendation that Microsoft gives us is what they call the landing zone, which is really a hub and spoke. We have our internet, our on-premise connection coming in into a hub VNet. That hub VNet is the one that then has either the clusters or the checkpoint scale sets or the security NVAs that are there to protect traffic. And then that connects to multiple VNets. But this, of course, also has a set of drawbacks. The most important one is the one at the very top that I highlighted there, which is a single point of failure. So from here, we move into checkpoints recommended solution. Basically, we looked at this and we said, what is the best way to tackle this so we do not have that single point of failure, but we retain the scalability and shared resources and minimize cost? And we came up with what we call our security blueprint. The idea behind the security blueprint is to minimize the amount of touch or modifications that you need to make to your existing deployments. So we don't care if you're thinking of deploying in Azure or whether you've been in Azure for 10 years and have a full set of VNets that span the globe, right? We wanted to create a blueprint that would make you adding security via our CloudGuard gateways or whatever next generation firewall that you have a lot easier, and would do so without impacting your existing systems. The squares that you see here that say spoke 1, spoke 2, spoke 3, those would be your VNets. They could be production VNets. They could be development VNets, testing VNets, multiple offices, maybe even partners are integrated with you. And we want to build sort of like a wall around the whole thing. And using the hub and spoke, what we did is instead of the single hub and spoke, we are recommending a dual hub and spoke scenario. So we have that northbound hub at the top. We have that southbound hub at the bottom. So if that were a castle and we have that cloud-shaped wall surrounding it, we have 2 entrances with guards in them. The northbound hub would be looking and inspecting anything that comes from the outside, from the internet. The southbound hub would be inspecting and looking at everything that's coming internally from on-prem, from MPLS networks, SD-WAN networks, any sort of partner networks perhaps. Those would be coming in through the southern hub, but the hubs would be redundant. And either one of them can perform both functions if needed. So what does that look like? On the right-hand side in this slide, we see the first typical deployment that was just 2 VNets, maybe joined by an express route to our system. And on the left-hand side, we now see we added that hub and spoke model with the checkpoint inspections on them. And then the traffic would come in through that inspection hub, and then from there move over to the original subnets that we had before. The VNets themselves are not changed. They're exactly the same as they were before. We just added a middle security hub that will be seeing that traffic, whether that traffic is moving from one VNet to another, whether that traffic is moving between the cloud and on-prem, whether the traffic is moving from on-prem into the cloud, or whether we have any sort of external services link associated with it, whether it's a service endpoint or a private link, it can be inspected as well. And by doing this, we're adding deep packet inspection of all protocols, not just web protocols. We're adding full threat prevention. We're adding zero-day capabilities. We're adding DLP and content awareness. So we have visibility into what the payloads have and be able to filter those as well. And we have a lot of expanded access control that is not normally available with the native solutions. This was Blueprint 1.0. And this is still a valid deployment concept. As you can see, it has both hubs. Instead of having the top at the bottom on this graph, we have them side by side. This is the external security, or the northbound hub that you saw at the top of that cloud-shaped wall. This one would be the internal security hub, and it's the one that is connecting to on-prem, while the external is connecting to the internet. The checkpoint inspection systems in here are normally scale sets. They could also be clusters for high availability. The main differentiation between scale sets and clusters for us is clusters gives you stateful failover. Scale sets do not, but clusters can only do basic HA. That is, they have an active and a standby node. They don't have any way to scale to 3, 4, 5, 6, or 10 members. Scale sets can. So you can begin your scale set with a single checkpoint system, and that can scale to 2, to 4, to 6, to 8 as needed, and it can scale back down. Our main recommendation is to go with scale sets whenever possible, because it gives you that capability to scale as needed or scale in the future. While starting very, very small. Again, you can have a scale set of a single gateway, and that is a supported configuration for us. If, however, you need stateful failover, or you're terminating VPNs in the checkpoint system, load balancers do not know how to deal with VPN tunnels very well. So in those cases, we do recommend active standby cluster, which is able to not only terminate VPN tunnels, but fail over traffic statefully. If most of your traffic is web-based, scale sets are perfectly fine. If your traffic is not web-based, if it is a connection-based traffic, things like RDP, SSH sessions, SFTP transfers, things of that nature that have a stateful connection that goes on, you are fully able to use clusters for that. And we have some customers that actually deploy both a scale set for web traffic that gives them dispensability, and a separate pair of checkpoints to terminate VPNs and to handle the traffic that is not web-based in that manner. Citrix sessions are also a popular stateful connection system. Azure services and the PaaS services. We support both service endpoints and private links coming into an infrastructure, and we normally basically connect them via peering to either the internal or the external security VNet. These can be directly in the VNet themselves because routing will allow it, but it's a lot cleaner if they're on their own system. It makes the UDRs a lot easier to implement. This solution is multi-cloud. Most of the information that I'm giving today is going to be Azure specific, and so far all the examples have been, but the exact same model can be very easily ported to multiple clouds. So you can be present in multiple clouds. You can have multiple systems in Azure, you can have multiple systems in AWS, multiple systems in Oracle, multiple systems in Google, GCP, in Ali Cloud if you are in the Asia Pacific region. And this particular architecture is fully workable and fully supported across all those systems. There are certain, not limitations, but accommodations made for the specific architectures. In this particular case, you see that AWS, for example, needs a TGW in order to be able to do a fully functional hub and spoke model, while Azure does not require that at all. Azure has a very powerful transitive properties inside of the hub that you can enable very easily. But we can adapt again and work with the other cloud models if you're doing a multi-cloud deployment. The next question that we normally get is, okay, I understand the concept. You want to basically add a couple of hubs to my existing network and put security on those hubs. Can that be automated? Is there any way, because I orchestrate everything, I build all my VNets using Terraform or using Ansible, I build them on the fly. Can I deploy security hubs with checkpoint systems on them fully automatically? And the answer, of course, is yes. We have templates for Terraform and Ansible examples available in GitHub. We have a Terraform provider already developed, and we have a close partnership with Ansible specifically for security. But if you are comfortable with Ansible and Terraform, we fully support those. We, of course, support almost any automation via our APIs. So if you're comfortable using PowerShell and the Microsoft development tools, you can fully orchestrate our deployments by just using the ARM deployment tools and PowerShell in Microsoft. Again, if you do not find examples on how to deploy something or configure something checkpoint-wise in GitHub or one of the shared depositories like Checkmates, for example, please reach out, and we will gladly connect you to an architect that specializes in that particular piece of automation, whether, again, it's Ansible, Terraform, PowerShell, or SaltStack, Chef, Puppet, you name it. So we have Blueprint 1.0, and that's how we started. But does this cover all current attack vectors? I mean, we were here before, and can we sit down and look at what we cover now? And do we have anything else to worry about? And here we are. I could think of several things that are not particularly covered by the blueprint as it exists today, because the blueprint is built to stop breaches or hack attempts that happen through the traffic by deep inspection. But there are multiple ways to access the cloud and multiple new perimeters. Dome9 is a company that we purchased a little over a year ago. It adds exposure analysis and audit reporting on cloud configurations. It adds configuration enforcement. It adds governance and compliance. It adds log enrichment and monitoring plus analytics. It adds auto remediation on any of the cloud configurations. We are trying to support checks not only for specific Dome9, best practices that Azure recommends for their environment, but of course for the most popular federal, state, and industry regulations. And we make it very, very easy to write your own. Think of Dome9 in this particular piece on the governance and compliance as an Azure policies in steroids. Azure policies today give you several things. They give you PCI, I believe they give you NIST. We give you not only 4 times more checks, but a lot more checks inside of the individual ones, right? We also give, and this is pretty unique to us, exposure analysis. We show you in a flowchart diagram after we analyze the cloud, what networks have access to your cloud today at this instant. If you do not recognize a network that we list, you can click on it and we will basically show you which specific component in the cloud that particular system has access to and over what ports. So we can give you a very quick view of how exposed you are to the outside. And you can very quickly classify the networks that get listed in here as internal networks that you control or networks that are completely external to your cloud. Under log enrichment, we have a module called Logic that comes with Dome9. And what we do is we start with the logs that come with the cloud, and then we add a lot of information to those logs. We enrich them. We add a lot of the metadata that we have learned via our connection through Dome9. Things like the offering, the version, whether it's Linux or Windows, the size of the VM, in addition, of course, to the IPs that are part of it. We also add IP geolocation data, so we know if something is coming from Brazil or from China or from Russia. We add threat cloud information, so we know if an IP that's listed on the logs is a malicious IP or not. And we give even more information than that. We tell you, not only is it a malicious IP, not only is it been talking to a particular system that you have, but we tell you this type. We don't only tell you where it's coming from Brazil in this case, but we tell you the type of malicious system that it is, whether it's a network scanner that is basically scrubbing through your systems trying to find an open port, whether it's a DDoS attack system, whether it's a command and control bot system. So we try to give you a lot of information and add this information to the logs so you can do very specific queries. You can say, I want to see every Windows system that I have on the cloud that is attached to a network security group that allows RDP from the outside and is open to countries outside of the United States, and maybe were flagged as vulnerable by my latest Tenable IO or Rapid7 scan. Because we can ingest that information as well. We can allow you to make those searches and get an immediate visual representation of what those logs say. That is what our blueprint looks like today. That is Blueprint 2.0. It includes our checkpoint gateways on the Security Hub, and it includes Dome9 and Logic associated with those as well. And between those three things, we're adding not only deep inspection of traffic coming from the internet, traffic coming from on-prem, traffic coming from MPLS or wider networks or SD-WAN networks, traffic moving from one VNet to another, traffic heading to the outside, including DLP and exfiltration. We're trying to make sure that the most amount of traffic is inspected in the most amount of directions without, again, being a big impact on your current deployments as they are. And Dome9 and Logic are, again, fully right now, they require no agents of any kind. It's just an API-based analysis and auditing of your network. So we do not connect to your network. We do not see what your traffic is from Dome9 or Logic. We don't have access to the contents of your servers, but we have access that allows us to analyze the logs and enrich them. And we have configuration auditing control, so we can let you know whether you're fully compliant with regulations or with your own set of requirements that you may have built.
Gustavo, we're starting to run out of time. We have 6. Oh, okay. Yes. So why don't you wrap it up? And
I'm there. Yes.
Okay, very good.
We have a document that describes and a white paper that describes the Blueprint 2.0 and all the piece parts. You can download that document usually from the support side. You're going to get this Q code if you got a copy of this slide, and you can get that link from here as well. Finally, I wanted to talk very quickly about Protego. I figured that could have been a question. It's an acquisition that we made recently that targets serverless. Dome9 does have a lot of controls to protecting serverless traffic. We are going to be expanding those by quite a big degree via the Protego acquisition and the ForceNock acquisition that we made last year. And with that, I think we can go to, I'm going to go ahead and stop my share and we can go to questions.